Hello students, a very good morning to all. Now, in this lecture we will study this method that is called separation of variables method. Right? Let me tell you something about this method. And in this method we will solve only, listen carefully, homogeneous differential equation. Homogeneous partial differential equation will be solved by this method only. Homogeneous means what? You can say this is 0, right? And also if you are going to transfer this term in this direction here LHS, then also this is gives 0 and this is minus u equal to 0. So these all are homogeneous partial differential equation. That's why we can use here separation of variables method. Okay, the name is clear, separation of variables means we will separate the variables. Now I will explain this concept by taking these three examples, and those examples are very important. Now let's see first example that we have, that is we have 3 times dever u dever x plus 2 dever u or dever y equal to 0. This is the problem we have. Now you can see here u is what? Dependent variable. Dependent variable, and x and y, these are independent variables. Independent variables, right? Now, so in this case what we'll do, first we assume the solution. Let u, this is dependent variable, I say this u is a function of capital X. This capital X is the function of x into capital Y is a function of small. This is the separation of variables. I separated here x and y, right? I put this equation 1. You have to assume this equation 1 according to the variables you have been given in the independent variables form. Here independent variable x and y, that's why I am taking here x of x and y of y. Suppose this is given t, so you have to write capital T of comma of small t, right? Okay, so this is the problem we have now. So what we have to do? First of all, we will find dever u upon dever x and dever u upon dever y. Why? Because we need here in the given equation we need dever u upon dever x and dever u upon dever y. So we need to find from this equation 1 dever u upon dever x and dever u upon dever y. So dever u over dever x, this is what? X dash, right? And this is capital Y, because this is capital Y is a constant and this function of x dash, so x dash. Similarly, dever u over dever y, we have x y dash, right? So now you have to just putting these two values of dever u upon dever x and dever y in the given equation. So we have 3 times. Now what is the value we have from the dever u upon dever x? X dash y. So x dash y plus 2 times dever u upon dever y, we have, that is x y dash, x y dash equal to 0, right? Let me tell you, we have, yes, Now here. So this is what now we can just solve. We will do the terms of x in one side and y on one side, right? So we can write here 3x dash y is equal to minus 2 times x y dash, right? Also we can do 3x dash upon capital X is equal to minus 2 y dash upon y, right? Now here I am telling you this these two quantity, we have two quantity, one this, second one this. They are equal, so I think they are both will be equal to any other constant, that is I can say lambda. See, right? So we can write first fraction 3x dash upon x equal to lambda. Now here we can solve, right? We will solve this problem. Now how will solve this? You can, I think, consider here 3x dash minus lambda x equal to 0. So this is what? Now this is homogeneous differential equation, but this is ordinary differential equation. Here we have taken only one independent variable, that is I can say capital X is function of only x. So this is one, that's why this is ordinary differential equation. And also homogeneous. Why this is homogeneous? Because this is 0, ये 0 है यहाँ पे, इसलिए homogeneous है. अब हम इसे सॉल्व करेंगे. इट्स वेरी सिंपल, राइट? नाउ कैसे सॉल्व करेंगे? लेट सी स्टार्ट. 3 we can write capital D minus lambda of x equal to 0, you can say, right? Now here capital D is equal to what? D over dx, right? So now what will be the here auxiliary equation? Auxiliary equation will be 3m minus lambda equal to 0. This is the auxiliary equation we have. So m is equal to, we have lambda upon 3. Lambda upon 3. Now the solution, CF कॉम्प्लीमेंट्री फंक्शन, ये होमोजीनियस है तो इसका कॉम्प्लीमेंट्री जो फंक्शन होगा वह इसका सोल्यूशन होगा, मतलब कैपिटल एक्स होगा. वो क्या होगा? आई कांस्टेंट C1 ई रेस्ट पावर मीन्स लैम्डा अपॉन 3. ये हमने कांस्टेंट जो माना ये हो गया C1 इज पावर कैपिटल एक्स. सिमिलरली अब हम क्या निकालेंगे? कैपिटल वाई निकालेंगे. वो कैसे निकालेंगे? लेट मी टेल यू. हमारे पास क्या है? माइनस 2y डैश अपॉन वाई इज इक्वल टू लैम्डा, माइनस 2y डैश अपॉन वाई इज इक्वल टू लैम्डा. सो आई कैन राइट हियर लैम्डा, सॉरी, 2y डैश प्लस lambda y equal to 0. So we can write here 2 again 2d plus lambda, right? Y equal to 0. Here d will be what? D over dy, right? So now this auxiliary equation will be here 2m plus lambda equal to 0. This is our auxiliary equation. So complementary function will be what here? M is equal to minus lambda upon 3. So let me see. Yes, M is equal to minus lambda upon 2. Minus lambda upon 2. माइनस लैम्डा अपॉन 2 भी है. सो हेयर जो कॉम्प्लीमेंट्री फंक्शन होगा वो सोल्यूशन होगा, दैट इज कैपिटल वाई. वो क्या होगा? C2 ई रेस्ट पावर माइनस लैम्डा अपॉन 2 आ गया, राइट। सो C1 C2 जो वैल्यू मीन्स हमारे पास कैपिटल Y, नाउ यू कैन सी we have the value of capital X here, again we have the value of, yes, this is X here, I forgot Y, right. So now substituting values of C1 C2 means the values of capital X and capital Y in equation 1. So we have U is equal to capital X the value C1 e raised to power lambda 3 lambda upon 3x, lambda upon 3x into C2 e raised to power minus lambda upon 2y. So you can, U is equal to capital A e raised to power lambda upon 3x e raised to power minus lambda to y, right. You can write here from equation 1. So this is the solution, right. Now let's see next problem. Second problem we are taking. Dever upon dever is equal to 4 dever upon, no. We have second problem. Dever u over dever x equal to 4 times dever u over dever y. There is a bound initial condition u of 0 comma y u of 0 8 e raised to power minus 3y, 8 e raised to power minus 3y. This is the problem, right. Again this is homogeneous, so we will use concept of separation of variables method. Now the solution. Solution is what? First we will take here, again here u is what? Dependent variable. This is dependent variable, and x and y, these are independent variable. These are independent variables. Now, so let the solution be here. Let u is equal to capital X of x, capital of y. This is equation 1. So again what we need here? We need dever u upon dever x and dever u upon dever y. So dever u upon dever x equal to capital X dash and y. Dever u upon dever y is equal to what we have? Capital X y dash. So you have to put these two values in the given equation, this, right. So we have dever upon dever x is equal to x dash y is equal to 4 times dever upon dever y x y dash. Let me see. Yes, x dash y is equal to 4 times 4x dash y. Right. So we will writing here this one. Now you can just, I'm telling you, you have to just put x dash upon capital X, the terms of x one side and the terms of y, that is another side. 4y dash upon y. This is another, say I constant, this is lambda, right. So now these two, so we will take one by one. First I am taking capital X upon capital X, sorry, x dash upon capital X equal to lambda. So you can write here capital X dash minus lambda x equal to 0. right? So you can write here d minus lambda x equal to 0. Here this capital D equivalent to d over dx, right? So this is homogeneous ordered differential equation with constant coefficients, right? सो हेयर होमोजीनियस तो कॉम्प्लीमेंट ऑक्सिलरी इक्वेशन क्या होगा यहाँ पर? जब ऑक्सिलरी इक्वेशन लिखेंगे तो हमारे पास क्या आएगा? m माइनस लैम्डा इक्वल टू 0. सो m इक्वल टू लैम्डा. कॉम्प्लीमेंट्री फंक्शन क्या आएगा? यही हमारा क्या होगा? सोल्यूशन होगा. सो क्या आएगा? c1 ई रेस्ट पावर लैम्डा व्हाट? लैम्डा स्मॉल x. ये आपका क्या आ गया? c1 e raised to power lambda x, capital X की वैल्यू है. Now we'll take for capital Y. So we have for y dash upon y is equal to lambda. So you can write for y dash minus lambda capital Y equal to 0. Right? You can write here for d minus lambda. For d, right, minus lambda y equal to 0. Here d is what? D over dy we have, right? Now in this case the auxiliary equations will be 4m minus lambda equal to 0. So m equal to we have lambda upon 4. Lambda upon 4, right? So complementary function CF मतलब solution what is here? This is homogeneous. तो complementary function क्या होगा? वही हमारा solution होगा. कैपिटल Y is equal to C2 e raised power lambda upon 4y. Now you have to put the values of capital X and capital Y in equation 1. So we have u is equal to, now put the value of capital X. That is we have C1 e raised power lambda x. C1 e raised power lambda x. Now the value of capital Y we have C2 e raised power lambda upon 4y. Right? You can write from 1. I am putting the value of capital X and capital Y. Now this can be written as capital A e raised power lambda x e raised power lambda upon 4y. Here I consider C1 C2 is equal to capital A, that is constant. Now this is equation second. Now here again you have to apply the boundary conditions. We have, now let me tell you, we have this equation u of 0 comma y is equal to 8 e raised power minus 3y, right? So let's see. Right? So u of 0 comma y, put x equal to 0 in the expression in this expression equation number set. So we have capital A into e raised power lambda upon 4y, because x equal to 0, so this is giving you value 1, right? So a raised power lambda upon 4y this. Now और यही हमारा e 0 comma y प्रॉब्लम के कितना गिवन है? लेट मी टेल यू, 8 e raised पावर minus 3y minus 3y, right? So you can calculate what will be here. Capital A is equal to will be 8 and what? Lambda upon 4 is equal to minus 3. So lambda is equal to we have minus 12. Lambda equal to we have minus 12 and A is equal to 8. So the solution u is equal to 8, right? E raised power, now see, from equation second we have A, that is 8, lambda e raised power lambda x, lambda is equal to you have minus 12, so this is minus 12x. Now we have e raised power lambda upon 4y. So this is minus 3. Lambda upon 4, that is minus 12 upon 4, that is minus 3y. So this is the solution of the right. Now see next problem here. Yes, we have derivative upon derivative x plus derivative upon derivative y equal to y. We have third problem, derivative or derivative x plus derivative upon derivative y equal to u. So this is homogeneous. How this is homogeneous? You can write derivative upon derivative x plus derivative upon derivative y minus u equal to 0. So this is homogeneous. So we can apply here separation of variable method. Right? Here u is what? U is independent variable. Sorry. Huge dependent variable huge here dependent variable and x and y, they are independent variable. They are independent variable, right? So now let me tell you, here we will take the solution. Let small u is equal to capital X of small x into capital Y of small y. This is a question mark. So first of all, what we need u, that is this. We need derivative upon derivative y. We need derivative upon derivative x. So first we need to find here derivative upon derivative x. This is x dash y. Then we need to find here derivative upon the y. This is ex y dash. Right? Now is this clear? Now, so we have to put these values u, derivative upon derivative x, derivative upon the y in the equation. Which equation? In the given equation, this. So now put derivative upon derivative x, that is x dash y, plus derivative upon the y, x y dash minus u, that is x into y equal to 0. Now you can choose previous u minus u, that is xy, x dash y plus xy dash minus xy. You can check here minus xy, that is u equal to 0, right? Now, so we can write here x dash minus x into y plus ex y dash equal to 0, right? So now we can write here x dash minus x into y is equal to, sorry, now it's that's correct. X dash minus x into y, x y dash equal to 0. We can write here minus x. Also we can write here x dash minus x upon capital X. This is minus y dash upon y. I said both are equal to lambda. Say minus y dash upon y, x dash minus x minus upon x. Now we'll take first x dash minus x upon x is equal to lambda. So this can be written as x dash minus x equal to lambda x, right? So we can get capital X dash minus x minus lambda x equal to 0, right? So here we can find x dash minus 1 plus lambda x equal to 0. Yes, you can take minus x common, right? So this becomes 1 plus lambda, right? Now this is homogeneous ordered differential equation with constant coefficient. I can write here capital D minus 1 plus lambda to x equal to 0. Here capital D stand for d over dx, d over dx, right? Now the actual equation we have m minus 1 plus lambda equal to 0. So we have m equal to 1 plus lambda. Here this is homogeneous, so जो complementary function होगा वही इसका solution होगा. So capital X is equal to c1 e raised power 1 plus lambda into x, right? Now we will take another next one, that is minus y dash upon y, minus y dash upon y equal to lambda. Say, let me check. Yes. Now, so what we have to do? Just we can write here y dash, right, plus lambda y equal to 0. Y dash plus lambda y equal to 0. You can write here d plus lambda y equal to 0. Here this capital D stand for d over d. Now the auxiliary equation we have m plus lambda equal to 0. So we have m equal to minus lambda. So कॉम्प्लीमेंट्री फंक्शन क्या होगा, ये इसका सलूशन होगा. सो कॉम्प्लीमेंट्री फंक्शन क्या होगा, दैट इज y इज इक्वल टू सलूशन c2 e raised power minus lambda y. Now you have to put the values of x and y in equation 1. So we have solution u is equal to so put capital X, that is c1 e raised power 1 plus lambda x, c1 e raised power 1 plus lambda into x, now into y, that is c2 e raised power minus lambda y. You can consider here u is equal to capital A e raised power 1 plus lambda x, right, into e raised power minus lambda y. Here c1 into c2 is equal to a. I can consider, you can write here from question 1. So this is the solution. Okay, so I have solved here 3 problems of separation of variables method, right? You can go through that. Okay, if any problem, then you can just reach out to me, right? Okay, so bye, take care, God bless you all, have a good day.